All right, so the first problem that you sent me was number 6. Determine the coordinates of the vertex of the quadratic function y equals negative x squared plus 6x minus 2. I'm doing this on a separate screen so I can write on it, so hopefully the lag isn't too bad. But when we're finding the coordinates for the vertex, if you're doing it by hand, obviously the easy way is go graph it and look. But if you're doing it by hand, there's a formula, and it's negative b divided by 2a. Now, you need to determine, of course, what is b and what is a. So if you look at the equation, you have 3 parts. You have negative x squared for one, 6x for the second one, and then negative 2 for the third. So each of those goes in alphabetical order, A, B, and then C. Sorry, the writing is a little off. It's a little awkward to write on this one. So all we're going to do then is go plug in to our formula. So we substitute, we have negative, and instead of b, it's going to be 6. That negative has to go with it, even though b is a positive 6. Because the formula says negative, we put a negative in front of it. And that is divided by 2 times the value of a, which in this case is negative 1. There is that invisible 1 in front of any variable if it doesn't already have a number. So in this case, it's going to be 1, and there's a negative with it, so it'll be negative 1. And then we just keep on simplifying, negative 6, and now 2 times negative 1 is negative 2. Negative 6 divided by negative 2 equals a positive 3. So that's the x value for the coordinate. So I'm going to put that up here for 3 for my x value. And then what we're going to do from here is just substitute back into the equation anytime we see x. And then once we simplify it, that'll tell us the y value. So we'll have y equals negative, and I'm going to put a parentheses every single time that I change x. So negative, and instead of x now, it's going to be parentheses 3, and then the square. Plus 6 times, instead of x, it's replaced with 3, minus 2. So you can do this by hand, of course. 3 squared is 9 with a negative in front of it. So negative 9 plus 6 times 3 is 18, and then minus 2 here. Now you can basically just add and subtract your numbers. 18 minus 9 is 9, and then that 9 remaining minus 2 is 7. So y equals 7. So for our coordinate here, it would be 3, 7, which I'm not sure if you are in person or if you're at home working, but either way, you have access to Desmos here. This is what I use for my kids in class, and I think it works wonderful. It's awesome, and it's free, and it'll graph everything for you. So if we just graph the initial equation, we should see that vertex be 3, 7. So let's check and just make sure that we have it correct. Negative x squared plus 6x minus 2. Minus 2, yep. And so the vertex is at highest or lowest point, and in this case, it's the highest or maximum. So it is at 3, 7, which is what we had here. So that's the answer for number 6, 3, 7. I'm going to pause the video while I go look at the next problem and get set up for that. Okay, so for your next one, I did a really very, very rough sketch of the graph. I don't have a way to do it on the picture, but it asks you about the axis of symmetry, and you already labeled that vertex at 1, 9, which is awesome. The axis of symmetry, if you're given the picture of the graph, it is just an axis of symmetry is basically like it cuts the graph exactly into 2 pieces and straight down the middle. And so the vertex is that middle point. So if we were to draw a line like this, that would be the axis of symmetry. And it's a vertical line. You can see it goes through the x-axis right here. And since it cuts through the x-axis, your axis of symmetry is going to be x equals the value of x in the vertex, which would be 1. So axis of symmetry is just x equals whatever the value is for the vertex. So in this case, x equals 1. All right, let me pause to go to the next one. Okay, so the next one that you have is number 11. This formula that I wrote here, this is just the vertex formula. It was included on the problem, but I want to talk about the different pieces of it because that might be maybe where you're struggling. I'm not sure, but I want to cover it just in case. So if you don't know it, you can skip through. But this piece A, this tells you, one, if it's a positive, if it's opening upwards or opening down. It'll open upwards, so it'll be like this if A is positive. It'll open downwards if A is negative. And also, whatever number for A determines if it's a stretch or a shrink. So a stretch is a whole number, so like a 1, 2, 3, 4, 5, 6, and so on. And a shrink is a fraction. So fraction is a smaller piece of a whole. So it gets smaller. It shrinks, basically. The x will always stay in it, just like any other normal equation. You always have an x and a y. That is same for here too. They don't change. This h, though, I don't know why it's not showing up on here. Okay, a huge delay there. The h is what changes side to side. So h, left or right. Okay. And then the k is what moves up and down the y-axis. Man, there is a big, big delay right now in this. All right, so k moves up or down. Okay. So the problem said write an equation of a downward opening parabola. So we need it to look like this one. So we're going to write our equation y equals, and for a, we're going to put negative because it has to open downwards. And then it wants you to have a vertex at 4, -2. So if there's a vertex at 4, -2, this is x and this is y. All you're going to do is put the 4 where h is because that's with the x in parentheses, and then -2 goes where k is. So we have our a negative, it was downward, and then we do x minus, and then our x value, because whatever x value has to stay in the parentheses with x. They don't move away from each other, they stay. So x minus 4, and then we put our square, and then plus the value of k, or essentially y in this case, plus -2, or we really say it to simplify it, -2. So let me show you this on a graph, and hopefully it will also help make a little bit more sense. On a quadratic, you have just the standard one. We call it a parent function. It's y equals x squared. So you can see here, y equals x squared. And then if we have the new equation that we wrote, we said y equals negative, and then we did our parentheses, x minus 4, close our parentheses, squared, -2. If we look, we're basically comparing our two vertex points. So you can see one vertex is here at 0, 0, and the other is at 4, -2. So it wanted us to have it downward opening, so we have that here. That was this negative. And then it wants a vertex at 4, -2. So you can see the vertex at 4 and -2. So when you put the number 4 in the parentheses with x, it makes it shift side to side like we talked about. And then when you put the value for y at the end, that makes the graph go up or down. All right, let me pause and get ready for the next one. Okay, so on the next page you have 11 again. I'm not going to do that one again, but I will go to do number 12. And it asks you to write the equation of a quadratic function that will shrink by a factor of 1/2, shift left and up. So you can use the same vertex form that is in number 11, which is y equals a times x minus h squared, and then plus k. All right, so remember, a is what makes the graph open up or open down. If a is positive, it opens up. If it's negative, it opens down. A also is where you put anything that is shrinking or stretching. So in this equation, it wants you to shrink by a factor of 1/2. So y equals our 1/2 because it was shrinking. And then we're going to have x minus whatever we have. So it wants us, so here, hold on, let me rewrite. H goes left or right. And K moves up or down. Okay. All right. So for the next part, if we keep reading on the problem, it says, so we had a shrink by a factor of 1/2, we did, and then to shift left 6. So it wants us to shift left. So that's going to be what we change our H to be. So it needs to shift left, and if we look on a graph here, let me just delete that one. We need it to go left. So if we're moving left, you can see that this would move into the negatives. So even though this formula says it's negative, we are going to add another one. We're going to say, okay, we're going to move to the left, which is -6 spaces, and then square. And then if we keep reading, it wants us to move up 3. There's nothing special with that, but if we look at the y-axis, we can see if we move up, that is going in a positive number direction. So we will say it is +3. Okay. So let's go graph this and compare from what's the parent function to see if it went left or if it went right. Oh, sorry. One thing I want to mention is this double negative right here with the x minus a -6. You never write it that way. Whenever it's two negatives together, it's always combines to become a plus. So it's really x plus 6 squared. And does notice if you do x minus a negative, it'll still get it for you though. All right, so we have y equals our shrink, which is 1/2. And then we have parentheses x now plus 6 and squared, and then it shifted up 3. So if we compare our two vertex points, our standard one at 0, 0, and then this new one that we just graphed, -6 and 3, you can see it, yes, moved left 6 and then also up 3. So this would be the correct formula. And let me show you, if you do put minus a -6, it still does the same graph. However, I'm sure your teacher does not and will not accept answers that way. I know I don't for my students. They have to do x plus 6. Okay, so let me pause and go to the next one. Oh, I didn't pause. All right, so now we're on number 13. And this one is stating, write the equation of a quadratic function that will reflect across the y-axis, stretch by a factor of 2, shift right, and down 4. So we've got a lot of things going on here. So the first part where it says it wants to reflect across the x-axis, that's a really convenient and just way to confuse you. way of saying that it wants to open downwards. So since it wants to reflect across the x or open downwards, like here, we know we need to have our equation y equals, at least start it with a negative. So we're opening downwards. If we keep reading, it then says to stretch by a factor of 2. And any stretching or shrinking is also replacing a, so we're just going to put 2. And then we have parentheses x will always stay, and the equation says subtract, so we're going to have our subtraction. Now we need to replace h. It says it needs to shift right 8 spaces. And if we look along our x-axis, shifting to the right moves in a positive direction, so we're just going to say 8. We don't have to put a negative sign or anything, it just says 8. Oh, I guess it would help if I went back here. Okay, so then we do, actually let me read. All right, so we shifted right 8, so we had now x minus 8, because the formula says a subtraction. Don't get confused by that. It says subtraction, but when we shift right, that number is positive, so we just put a positive 8. And then it's going down 4. On our graph, if we look, when we move downwards, these are negative, so we're going to make it a negative 4. So if we go check our graph, compare it to our normal one, we're going to graph this function. Y equals negative 2. That was our reflecting and our stretching. And then we had x minus 8. That was the shifting to the right squared. And then it needed us to shift down. So we said minus 4. And if we look at our graph here, we can compare our two graphs, our two vertex points. So we can see first off, this graph started opening up. This one, it opens downwards, so it's a reflection. This vertex at 0, and now we have one at 8, so we know we moved to the right 8 spaces, and then we also came down 4. All right, and let me pause for the next. Okay, so this one on number 14, it is asking about the y-intercept. I'm not sure, again, what you know about a y-intercept, but a y-intercept is essentially where does the line, or in this case a parabola, cross along the y-axis. So for instance, if it was right here at negative 2, then that coordinate would be 0, negative 2. If it was down here at negative 4, the coordinate would be 0, negative 4. So no matter what spot you pick on the y-axis, the value of x is always going to be 0. So for anything with a y-intercept, all you need to do is go put 0 in for x, because you know for the y-intercept, it's always going to be 0, and then whatever your y value is for x. So we're going to go and plug in 0. Y equals negative 0 squared plus 2 times 0 minus 8. Well, 0 squared is just 0, so it doesn't even matter about that negative or anything. It's just going to be 0. It's not included. 2 times 0 is also 0. So therefore, our y-intercept, the only thing that's left, would be negative 8. And if we go and graph and check our work, we're going to graph this whole equation. Y equals, it was negative x squared plus 2x minus 8. So let's go look. Where's that graph at? Oh, all the way down here. All right. Oh, that's the vertex, the y-intercept, where it crosses the y-axis. I was like, oh no, I got the answer wrong. Here at negative 8. So that's what we had here for the y-intercept, negative 8. So we can actually even fill it in here, negative 8. I'm not sure how your teacher is asking it because there's not like a parentheses to write it like this. So she may just be asking you to write it, or he may just be asking you to write it like this. I'm not sure. All right, 2 more. Let me pause while I clear this up. Okay, so for number 15, it gives you an equation, y equals -2. So you know it opens down, has a stretch of 2, times x plus 6 squared, so it shifted to the left, and then -2, it went down. It now wants you, though, to use that equation from that being your starting point, and it wants you to move the graph up 4 and left 3. So if we remember, up 4 is what moving up and down changes the y, or basically k, in our equation, and moving left to right changes x, or h. So when you do this equation here, you're going to keep the -2 and then do x plus 6, but now to move left, you are going to change that. So remember, moving left makes it a negative. So when we shift left, we're going to say, okay, now we're subtracting 3 squared. Now it's -2, but I also now shifted up 4. So I'm going to say -2, but now it moved up 4 spaces. And then we're just going to simplify. We can simplify 6 minus 3. So y equals -2, and then x, and then 6 minus 3 is 3. So we say plus 3 squared. And then we can also simplify -2 plus 4 to get a +2. And now we're going to go and graph both of these. We're going to graph this first one and this second one to check and make sure that it did move up 4 spaces and to the left 3. So let's come back here. We now are not comparing to the normal x squared. We are comparing to the new equation that they gave us, that they started with. And that was x plus 6 and square -2. And then y equals -2 times x plus 3 square plus 2. Not plus 0, plus 2. All right, so if we compare our two vertex points here, we should see a shift moving from the purple. Did we move from the left or from, let me go read this problem. Up 4 and to the left. Okay, so it went up, but we made it go to the right. Let me see, go back and see what did I do wrong. It was x plus 6 squared. Let me pause while I think through this. Okay, so I figured it out. I know what it should be, and hopefully this does not confuse you. I'm so sorry if it does. So in our normal formula, it has x, like in the parentheses, it's x minus h, right? And so when we said we were going to the left, I should have said, instead of this, I should have said x plus 6 like it was normally, but this formula says subtract, so we're subtracting whatever the difference is that we're doing. So since the formula says subtract and we know we're moving to the left, we already talked about that is to the negative side, so I'm going to do its -3 spaces and then square. So it started out, let me just erase this because I feel like that's super confusing. All right, it started out x plus 6. And the formula says subtract, so we're going to put that in, subtracting. And then it says shift left 3 spaces. So if we look on our x-axis, moving left makes that a negative. So when we fill it in, we're going to say -3 spaces. which I told you earlier, if it's two negatives by each other, they actually will join and become a positive or a plus sign. And it is lagging again. Okay, there it goes. So then now we can simplify here. So the -2 stayed, that didn't change. And then we'll have x, and now 6 plus 3 is 9, and then squared. The y, or this k in this place, didn't change. That one was done correctly. So it's -2 plus 4, and we still have -2. So if we go change that on our calculator where we were checking, instead of saying plus 3, I'll say plus 9. And you can see, okay, now from the purple to the black, it did move over 3 and then up 4 spaces. So we went over 1, 2, I can't even tell where we're at. Okay, from here, 1, 2, 3 spaces, and then up 1, 2, 3, 4 spaces. Or you can look, -6 to 9 is 3, and then 2 to 2, or -2 to +2 is 4. All right, so that was that one. Let me do this last one. All right, so here's number 16. It has the formula or the equation y equals 2x squared minus 6. It tells us we need to shift right to the 3 and up 7 spaces. This was just for us to reference here. This was the vertex formula, y equals a times x minus h squared plus k. So if you remember, h is what shifts left to right, so this is going to be h, and k is what shifts up or down. So we're going to change our equation. We have y equals, that 2 will stay, but now since we're moving to the left, I'm going to have to do my parentheses with x. Or sorry, we're doing to the right, not left. So we're going to do x, and then the formula has us subtracting, so we put our little subtraction. So that's here. And then we need to make it shift to the right. Right? Yes, to the right. Let me just reread that. Yes. Okay. So if we're looking at our graph, going to the right is a positive number, so I'm not going to do anything special. I'm just going to put 3 because that's how many it was shifting right, squared. Now we had -6, so we're going to keep that there, but we also now want to shift up 7. Oh, let me go back here. So we had -6, that just stayed, and we're shifting up 7 spaces. So again, moving up is a positive thing. So when we rewrite this, we're going to say, okay, plus 7. We were at -6, now we're moving up 7 spaces. So this part, on our next line, we can simplify this. So we have y equals 2 times x minus 3 squared, and then -6 plus 7 is 1, so plus 1. So let's go graph and check. So we'll graph both equations and make sure that it moved in the right direction this time. Y equals 2x squared minus 6, and then y equals 2x minus 3 squared plus 1. So we needed to go to the right 3, so comparing one vertex to the other, we have, click, 0. It did move right to 3, and then it also went from -6 to 1, so it went up 7 spaces. Okay, so that's that. I hope that helps. I'm not sure kind of like what you're grasping and where you're at, but that is a quick, really quick-ish recap of how to do all of those problems. Let me know if you still need any additional help or clarification on any of this.